Off to the races. These two are late to class.
No, I was here. I was here with Dominic and Robert.
On YouTube, you guys are going to be late to class. All right, so we're talking about special products of polynomials. So a special product is, it really comes from having a unique setup to our problems. So in this first example, example A, kind of moving, actually let's move backwards just a second. If we say find the product, what operation are we using? Multiplication. And when we're multiplying polynomials together, we use the box method. So x plus 5 squared, if we were to write this out, this is x plus 5, and then another x plus 5. And then this line here looks more like what we've had in the past that we can use our box method on. So as we review the box method, you draw your box. If it's a binomial times a binomial, it should have 2 rows and 2 columns. You put your first parentheses on the top. So have an x plus 5 on the top. And then you put your second parentheses on the side. So another x plus 5. And at this step now, you do not do any adding. To go into your boxes, you multiply, like a multiplication chart you had when you were in elementary school. You multiply the two numbers together, you follow it into the inside. That's where your product is.
1x squared.
Yes, we can write as 1x squared. I'm just going to do x squared. 5 times x, that's 5x. In this box, we also have a 5x. And then 5 times 5 is 25. And these two terms are the same. They're like terms, so we can combine them. So our final answer would be x squared plus 10x plus 25. A trinomial, second degree with the leading coefficient of 1, if you wanted to put that there. All right, so for the next one, you'll take x minus, was it x minus 9 and x minus 9? So set up your box. You gotta make sure when you're multiplying the negative by a negative, it becomes a positive. And when you're multiplying negative by a positive, it stays negative. So again, we could have x squared, negative 9x, negative 9x, and then a positive 81. So then we can combine our like terms on our diagonal. X squared, and now when we're combining like terms, we add. So we have negative 9x plus negative 9x. We're just adding the coefficients. So it'll be negative 18x plus 81. Third example, we have now a coefficient in front of our x in our binomial. So again, this is just 3x plus 4. Since it's squared, it's being multiplied by itself. So label your rows and your columns. So 3x times 3x, you multiply your coefficients. So 3 times 3, that's 9. And then you add the powers on your variable. So x times x is x squared. So in our top box, we have 9x squared. Then we have a 12x, 12x, and then 16. So our final answer is 9x squared plus 24x plus 16. So far through these three examples, what do you notice about our like terms that are on our diagonal? They're always going to be the same. So if you're squaring something, your diagonal term should always be the same. So this is 5x, this is 5x. This is negative 9x, this is negative 9x. This is 12 and this is 12. So if we do example D, we'll have the same deal. 2x minus 3, 2x minus 3. This is 4x squared minus 6x, negative 6x. Negative times negative is a positive, and again, these two diagonal terms are the same. That's good. We're doing it right. So our final answer will be 4x squared minus 12x plus 9. Nothing too tough. I could have given you this problem last week and you would have been able to do it. It's kind of now looking at it from a different perspective. If you go to the three examples on the bottom, why we call this a special product is because we have a plus 5 and a minus 5 up here. So we have the same term, it's just one's positive, one's negative. And when we have that, we'll kind of have, like we did on the other problems, something consistent happening along our diagonal. This is plus 5, and this is x minus 5. Here we have x squared, positive 5x, negative 5x, and negative 25. Looking at our like terms now, they cancel each other out because we have a positive and negative of the same number, so it goes to 0. So we wanted to write this as three terms before simplifying. It would be x squared plus 0x plus 25. But 0 times x is always going to be 0. So you could just write your final answer as x squared plus 25. The board's either going to catch up to me or disconnect. There we go. It caught up to me. Sorry, it should be minus 25. I said minus, but didn't write minus. Minus, minus. Yeah. Sure. All right, next one, we're going to do the same deal. We have a plus 3 and then an x minus 3. So you have x squared, 3x, negative 3x, and then negative 9. So these middle terms will cancel, so x squared minus 9 be your final answer. So really what all we're doing in our final answer, it's our front terms multiplied together and then our back terms multiplied together because everything else cancels. So if I look at C, I can do C without even using the box because I know it's a minus and there's a plus, so I know my middle term is going to be a 0x. I know on one side, my leading term, if I take 2x plus 2x, that would be 4x squared. If I take 1, negative 1 times 1, this will be a negative 1. So my answer is 4x squared minus 1. I could do it without even using the box, knowing that my middle term will be 0. I just think, okay, what would be my top left corner of my box? What's my bottom right corner of my box? It would be 4x squared. I guess if you do it this way, this would be a negative 2x, a positive 2x, a negative 1. These cancel out. We're left with 4x minus 1, 4x squared minus 1.